This session we discuss about logical connectives and truth tables. So we start by defining what we mean by an atomic proposition. Definition. So a proposition actually a statement that is simple, declarative, is called an elementary or atomic proposition. So this is the main thing. So propositions that are simple declarative sentences are called elementary or atomic propositions. So e.g., you can say Earth is the closest planet to the sun. Or we can have another atomic proposition as 1 plus 4 equals to 8. Or we can have another atomic proposition as sugar causes tooth decay. So these are examples of atomic or elementary propositions. Now, what we call logical connectives or logical operator so definition, a logical connective also called a logical operator is a word or symbol used to connect two or more atomic propositions in a grammatically valid way such that the compound statement produced has a truth value dependent on the respective truth values of the atomic statements or propositions and the particular . Connective or connectives used to link them. So that's what we call logical connective or logical operator. Word is simple that is used to connect two or more atomic or simple propositions in a grammatically valid way, such that the compound statement produced has a truth value dependent on the respective truth values of the atomic statements and particular connective or connectives used to link the atomic propositions. Now, a table which summarizes the truth values of a proposition is called a truth table. Now, since each variable can either assume T or F as truth value, the truth table for an expression having n independent variables has exactly two raised power n rows. And this is very key. For example, e.g., if we have two propositions A and B, then the truth table has two raised power. There are two of them, which is 4 rows. And then if we have A, B, and C as propositions, then the truth table will have 2 raised power 3, which is 8 rows. Now, let's list the logical connectives that we are going to discuss in this topic. Logical connectives. So one is what we call negation. So abbreviated by this sign or this sign. And then number 2 is what we call conjunction. abbreviated by this sign. There's 3, disjunction, abbreviated by this. And then number 4 is what we call exclusive or disjunction that's exclusive, abbreviated by this sign. Number 5, implication, abbreviated by this sign. And then by conditional, abbreviated by this sign. So let's discuss the first logical connective, and then others we'll discuss in the next session. So negation. So we need two proposition. We need a proposition to be able now to help us define negation. So let P be a proposition. Then the negation of P comma denoted by write this, or we write this, or by P is a denial of P, i.e. is the statement it is not the case that P, or simply means not P. So for example, 1, if we have the proposition it is raining, then not P will be it is not the case that it is raining. Or we can say not P, simply it is not. You are denying what P was, raining. If we have a statement such as all dogs are black, then not A, or the negation of A can be it is not the case that all dogs are black. Or you can say the negation of this proposition is not all dogs are black. Or you can say all dogs are not black. So those are possible ways of writing the denial of that proposition, or simply negation of the proposition. So truth table. The negation statement, the negation of a statement, P, has the opposite truth value of P. So if the truth value of P is true, then its negation will be false, and vice versa. So this is how we draw the table. So if this is P, and then this is not P, the negation, P can either be true or false. Those are the only possibilities. Now, when the proposition P is true, its negation will be false. And when it is false, its negation will be true. So that is how we discuss about the negation connective. Next session, we'll be discussing about the next logical connective, the so-called conjunction. Thank you.